This video will discuss using reference parameters in the design process, very specifically the 6-step programming process design process. We'll take a look at how we would design a handful of small functions, including those with reference parameters and those without. Let's go ahead and take a look at our environment here. We have just our base environment here. I have a program that basically I just want to get data from the user. I want to get 3 values from the user in any order, and then I want to return them to the user as a sorted group in order from the way they came through. And we'll just take in integers and we'll just do a very simple sort, but we'll take a look at doing that with some simple functions here. So in a nutshell here, we'll take a look at our first item on the business here is to just get the data, get the input from the user. We will in fact sort the 3 values, and then we will display them, and then we can end the program. So that's our step 1. We can compile, make sure that this is happy. We're all good there. We come through with our step 2, and in the step 2 we could break out this get input from the user. We could break it into getting 3 items. But rather than doing that, I want to abstract this and use a function. So I'm going to use one function to get 3 values from the user. And then I will go ahead and sort the 3 values, and then I will display those values. So we're pretty much through step 2 already here. Our initialized variable, I guess we could go ahead and show a title here. And then otherwise we're pretty much ready to go. So that's our step 2. Now if we're going to go into step 3, then we can go in and use the function. We'll get ourselves a function called showTitle. And to do that, we'll have to come up here and we'll get our and then we'll have our process will be simply to show title with underline, and then our function input as parameters will be nothing. This is just going to be just going to display a title. Our function output with parameters doesn't do anything here either. Again, this is not a processing function. And then our function output with returned won't have anything again. Again, this is not a processing function. The device input won't have anything. There's nothing the user has to do specifically for this part. However, the device output by way of the monitor will take out and show the title as specified. And for dependencies, we will use the IOStream IO tools. And with that in mind, our output returned is none, and so be a show title, so void show title, no parameters. Take that guy, copy him, take him to the bottom. And nothing to return there. We should be able to compile. Happy compiler. And we can go back up again and work some more here. So get input from user. I'm going to use a function for that, even though there's 3 items. So I'm going to say function get input. Keep it simple there. We will come up here and we will put in our little template right here. And start filling in blanks here. This is going to be get input. The process is going to be get 3 values from user. Function input parameters. Actually, this function isn't going to take anything in because it's going to get the data from the user and pass it back. So there really isn't anything to send into this function. However, coming out of the function, we will get the 3 values. And we notice that we have to get that back from the parameters because the parameters can send me back 3 values, where if I use the function returned, I can only get 1 value out of that. So I won't use the returned on this right here, but I will use the function parameters to get those 3 values back. Device input, we'll use a keyboard, and we will get, let's see, for the keyboard, the user enters data when prompted, and the output on the monitor will be prompt user for input. Dependencies is definitely going to be IOStream IO tools. With that in mind, I can now take a look and say this has a function return of none, so that's void. Get input. I don't have any parameters to get into this, but I do have 3 parameters to get out of it. So I'm going to say, I'll say int ampersand input 1, int ampersand input 2, and int ampersand input 3. Now what I have accomplished here, these are reference parameters. These are aliases for the variables that will be called in the calling function, in the main function. And these are going to be output products of this function that are in fact placed inside the parameter list. All right, with that in mind, copy this. Notice there's nothing to return here, so we don't have to deal with that. We will compile, and we're ready to go back and look at it some more here. So sort the 3 values. This is going to be an interesting one. We will just call it sort values. We'll come up here, and we will put in our template. And the name of this one is sort values. The process is sort 3 variables, return sorted. Input parameters, so we're going to have to send 3 variables into this. So the 3 values are going to go into it. And they go in any old order. However, the output in that same parameter list, we will have 3 values sorted, and that will come out. Those will still be integers. We won't have anything to return from this because returning can only send back 1 thing, and we need 3 things. This is a processing function, so device input doesn't happen, and device output doesn't happen. And the dependencies on this, at this point, we don't know what we might need, so we'll go ahead and put none on that. And then when we come in here, we'll have void, sort values. Now our input parameters are 3 values, but as it turns out, our output parameters will be those same 3 values. So we're going to have, once again, int val1, and in this case we will have an ampersand val1, int ampersand val2, and int ampersand val3. Now again, to note, this is input and output for this function. These 3 values will be passed into this function in whatever order, but when they're passed back, they will be in sorted order. And truthfully, again, remember, when they're passed back, it's not the values that are being passed back, it is the aliases. So what will have happened is, while we were sorting those values, we will have been sorting the ones in the main function. So we'll come back and talk about that momentarily. All right, and no return on that. Go back to our main function again, display the values. This is going to be pretty straightforward. Display values, and that's not much to that. We'll go ahead and get our template and place it right there. This will be display values, the process will be to display the 3 sorted values in order. Input will be those values. Now this isn't a processing function. It's really not going to return anything back out of it. So there won't be anything to return as parameters, and there won't be anything to return as a returned quantity. There's no real device input to this. However, we will be using the monitor to show device output, to show the system output, and that will be values displayed as specified. Dependencies here is almost certainly going to be IOStream IO. If we need anything else, we'll take a look later. Once again, I come down here, nothing returned, display values, and then I'll take in my 3 values, int val1, int val2, and int val3. Now, I don't need reference parameters for this because, first of all, there's no processing in here. There won't be anything changed in here. All I'm doing is passing the data in to be displayed on the screen. So what the bottom line on that means is that there's no need for reference parameters here, and you should not use reference parameters unless you absolutely need them. I'll copy that guy, paste him, no return quantities, happy compiler, and our function system pause is already placed in here. So we really should have the program ready to go. This should take care of all the business that we need to take care of in this program. So we will move on to step 4. Step 4 requires that we show the title. As I recall, that did not have any parameters. So we should be able to compile that and be happy. Okay, for get input from user, now we're going to have to send 3 variables out to get data from the user. So in this particular place, we'll get a get input, and we'll call it value1, value2, and value3. Those are our actual parameters. In fact, they're the variables in the main function. And we will go ahead and make sure they're happy with that. We're happy. We're going to sort the values. Make that pretty short work here. Value 1, value 2, and value 3. Now when we got them in here, they could be in any order. We have no idea what order they're in. And going into sort values, again, we won't know what order they are going in, but we will know what order they are coming out when this is done. So we'll compile that. Happy compiler. And once again, we'll just paste that right in there. We're going to display the values here. And we will compile that. This one right here, we sent numbers. There was no input to this function, but the output came, these 3 values, from getting from the user. This one, these 3 values were the input, and the modified data will come back through them as the output of this function. In this case, I'm simply passing 3 values in, the copies of 3 values actually, and those will be gone in and displayed to the screen. With that in mind, we'll do one more compile. We have a happy compiler, and step 4 is complete. Notice how very readable, eminently readable. Notice how clean this is using this format here. You don't always have to do that. The get input could be broken out, as we've done many times before, but I want to show and kind of exaggerate how we can do these at the same time that I'm exaggerating the different ways that we'll use this. In this case, no input to this function, but 3 outputs. In this case, 3 inputs, 3 outputs. In this case, only 3 inputs and nothing else. So that's step 4. And we can move on now to step 5 to design our functions here. So we will come down here. We'll set up our initialize function variables. Yes, we only have 4 functions here. That was easy enough. And then we'll come here, and the show title part right here will be simply show title. And then we will show the underline with an extra vertical space so that we have a space after the title before we start getting input. And that's step 1. Step 2 not going to break down much more. Step 3, we will use the IOStream insertion operator. And in fact, for this part right here, we'll do the same thing. So that's our step 1, 2, and 3 inside of the show title function. The get input function, we're going to have to prompt the user for the first value. And then we will get input, and we'll just say we'll get the first value. We're going to do this 3 times. Okay, so we prompt the user for the first value and get that one, prompt it for the second value and get that one, and then prompt for the third value and get that one. These are all going to be pretty straightforward in terms of functions. This function right here will be insertion, as will the other prompts. This right here operation will be extraction, as will the other 2 input quantities. And we can now take a look at that. We have a prompt for the user, get, prompt and get, prompt and get. Should be able to compile and be happy there. Now the sort values is going to become more interesting. Probably we are going to have some variables on that one. We'll have to see. But what we will do here is we will we'll get the highest value, and then we will get the lowest value. Those are easy to come by. And we will check if val1 is highest value. And if that is the case, we will check if val2 is lowest value. And if that is the case, then we will set the mid value to val3. Otherwise, assume val2, well, we'll just assume that val3 is the lowest out of this, and in which case we can set the mid value to val2. So follow that logic. First we just check and see if val1 is the highest value. If that's the case, then we're going to say, okay, is val2 the lowest value? If it is, then the mid value is val3. If it's not, then obviously the mid value is val2. Okay, we can repeat this process a couple more times. And we will modify these slightly as we go along. But I will ask now if val2 is the highest value. If it is the highest value, then I'll ask if val1 is the lowest value. If val2 is the highest and val1 is the lowest, then the mid value is val3. If it's not, val1 is not the lowest, then we will assume that val3 is the lowest. And we'll set the mid value to val1. We'll set the lowest to val1. Because if val1 isn't the lowest, then it's the mid value. Okay, so if for value 2 is the highest, If val1 is the lowest, then val3 is the middle one. If val1 is not the lowest, then val3 is the lowest. We'll make that assumption logically, and then we'll set mid value to val1. Finally, we really don't have to check anything here. This is an otherwise, as this should be here. None of these, only one of these checks should happen once it goes through. But we'll say otherwise, we'll assume that val3 is the highest value. If that is the case, we'll ask the question if val2 is the lowest value. If it is, then value 1 will be the mid value. But if not, if we assume that val2 is in fact the lowest, no, that would be val1 is the lowest, then we'll set the mid value to val2. So again, to check that logic, val3 is the highest. We're making that assumption because we've already tried the other two. We check val2, see if it's the lowest, and if it is, the mid value is val1. But if val2 is not the lowest, then we can assume val1 is the lowest and set our mid value to val2. Now, having done all that, then all we really need to do then is set 3 values to output parameters, and that's it. We'll set the mid value to, and truthfully, all we have to do is assign them back to val1, val2, and val3, which are these guys. We'll have to have check these mid values. These will be temporary quantities. Okay, so that's all we're going to have to do to solve that one. Pass them in, bring them in as values. We'll send them back. We'll send back the same values, but not necessarily in the same order. All right, and then display values is going to be pretty straightforward. We will show values in sorted order, and I realize we still need to do step 3 in the previous function. We'll finish this one first. This is going to be function, and we'll just use IOStream insertion, and then we will add with extra vertical space, and that'll all just be in one place. All right, and again, I came back to this one. I went through step 1 and step 2. Well, step 1. Step 2 is not that necessary because we're really not going any deeper. This is all, by the way, step 1 because it is all of what is required to solve the problem. But what I didn't put in here are any functions I might need, and in fact, I do need some functions. I need a function called getHighestValue. And I need to come back up here, and I will put my template in there, and that's get highest value. The process is to find highest value in group of 3, return. Input parameters will be 3 values. There won't be any output parameters on this. I'm only going to return one item, and that one item will be highest value, and that's an int. This is a processing function. Nothing happens in input or output. Dependencies here. This is really just some if tests, so I don't think we'll have any there. And now I'll come back, so I have an integer for return, get highest value, and then I'll have int val1, int val2, int val3, and understand now these also do not have to have reference parameters or be reference parameters, because all I have to do is pass copies in, because I'm going to look at them and I'm going to pick one of them out and send it back as a return as the highest value. So I'm not returning more than one thing. I'll use my return quantity. I will not use the reference parameters. We'll take this guy, take him to the bottom. This one does have a return net requirement, so we will just say return 0. temporary stub return. We will compile, and then we know that actually we're going to have to get the same thing for this guy. Get the lowest value. Alright, and so for that one we're just going to come up here and do a little hanky-panky with this part here. Value in the group of 3, return, 3 values in, lowest out, and then save that, and we'll paste that there, and that there, and we should be able to compile again. We have a happy compiler. And now note that sort values now depends on a couple of functions. We know that this is all if statements right here, so there's nothing else happening function-wise. But now we do note that sort values now uses the get highest and get lowest functions. So we need to put that in here, get highest value and get lowest value. Alright, we'll say we're going to compile to save it. And we're on our way down. So now we have that one completed. We've gone through step 1, 2, and 3 through there. We have the display values here. And then now we're going to get the highest value. That is very easy to do. We'll do initialize function variables. We will very specifically initialize we'll say the largest value to first value. Always use the data from the set to do finding of maxes or mins. Never make up numbers that might be high or low. You'll get bit. So we'll initialize that for that largest value to that value. With that in mind, then we will check to see if second value is larger than largest. And if it is, we will set the largest to second value. And then we'll do the same thing if once we've gone through that. No, there's no otherwise here. We're checking each one independently. Check to see if the third value is larger than the largest. If that's the case, then we will set the largest to the third value. And then when we're done, we will return the largest value. Alright? Pretty straightforward. This is a very easy find max in a group of 3. We'll compile and save, and we will go ahead and cheat here also, because the get lowest value is exactly the same thing, only backwards. We will initialize the smallest value to the first value. We'll see if the second value is smaller than the largest, smaller than the smallest. If it is, we'll set the smallest to the second value. And then finally, so really it's just the same thing, only we're looking at the bottom end. All we're going to do is turn around a test equals a greater than or equal, turn greater than sign into a less than sign. Turn it around, and that's it. So that'll get our get lowest value. We'll compile and save. And none of these require, neither one of these requires functions, so we don't have a step 3 component to those. And so we really are now finished with step 5 for all these functions, including 2 functions we had to generate to be used inside this other function, when we were going to find the or actually sort the values. It's not uncommon at all. And so now finally we're ready to go on to step 6, and all we will do is start from the top here and just implement each of our functions. For our show title, we will see out. We'll just call it, well, first of all we'll break a line here at the top, and then we'll give it a couple spaces. Sorting program. And we'll show an extra indel down here to make a space. And a couple lines of code. We'll compile it. Looks good. We'll get our input. This is going to be cout. Give it a couple spaces. Enter first value. No indel, nothing on there. We just put that in there. Copy these guys and take a little time here. Second value. Third value. And then we will better compile, make sure those guys are doing okay. And then we will do a cin. And now really we could make up our variables here, but we've already got aliases right now for the variables that called in, the actual parameters that called this. So we will just take those and put them straight into those parameters. Cin input 1. We'll cin input 2. And we'll cin input 3. We'll compile. Looks like we're in good shape there. So I've prompted for the first input, and then I got it. Prompted for the second input, and then I got it. Prompted for the third input, and then I got it. I believe we're ready to go here. All right, so now we'll go into sort values. We'll take a variable we'll call largest, and we will get highest value. And the highest value is going to come from each one of these guys, from the whole set. Doesn't even matter what order we put these in. I'm going to have to declare largest now. And got it, but not using it yet. Smallest, get lowest value, same parameter set. We're passing these in as copy parameters. They are reference parameters from the function that called sort values. These are aliases for those actual parameters up in main. But now from here to this function and to this function, we're passing them to here as copy parameters. They will be copied into the get highest value and get lowest value functions and then be used inside of there. And their changes, anything that changes them inside these functions, does not happen in the called function. Check our compiler here, and we do need to make sure we declare the smallest variable. And we have a happy compiler there. And now we do a series of if statements. We just say val1 is the highest. And come down here. We'll check if val2 is the lowest. And I think we said smallest. And if that is the case, then we'll have a mid value will be assigned val3. I'm going to have to create a mid value. and I believe we can compile there. All right, and then we'll do an otherwise, and I like to break that up. We will set the mid value to val2. All right, now we're just going to do this all over again. This is an else if val2 is the highest value. If that is the case, then we will check to see if val1 is the lowest value. If that is the case, then we'll set our mid value to val3. Otherwise, we can assume that val3 is the lowest. And we'll set our mid value to val1. Quick compile. Happy compiler. And finally, we have an otherwise, and again, we've already tested for val1 and val2. If they've failed, the only other possibility is that val3 is the largest. So we just don't have to do a test on that. And we will have a check if val2 is the lowest value. If val2 is the lowest value, then val1 must be the middle value. If val2 is not the smallest, then val2 must be the middle one. Another quick compile. Looks like we're looking pretty good here. And so now finally what we have to do here is we have to say, okay, fine, we found, I know what the largest here is, I know what the smallest here is, and now after this series of tests, I know what the middle one is. And by the way, there are ways to logically reduce this. I have two reasons for doing it the long-winded way here. And one of them is simply educational. I just want to show you my logic as I do this. But the second is also this is very readable. It's very logical that I check val1 and then the condition of val2 and 3, or val2 and the condition of val1 and 3, or val3 and the condition of val1 and 2. So I've tried to make it both readable and also educationally effective. But now the bottom line is when the smoke all clears, these values have to have the data in exactly the right order. So we will take val1 here, and we will assign it the smallest. We will take val2, and we will assign it the mid value. And we will take val3, and we will assign it the largest value. Now notice I waited to the very end to change the data in these variables, because if I changed it prior to this point, I'd possibly lose some data here inside of any one of these guys. I had to keep that data to do the analysis. So I did the very last thing as I set the three values to the output parameters. We will compile, and we have a happy compiler. All right, the display values is going to be pretty easy. We will do a cout. We'll do an endl here to break the line. And then we'll say values in sorted order. And then we'll do val1. Do a comma space. val2. Comma space, val3, And then we will do, come back down here I guess, do a couple of end-ls to keep a break between this and the end of the program. Go ahead, that is a line of code, compiled and very happy. Now, we were cruising along here. This is not taking terribly long, but we did, going through all 6 steps of the process, and we're at the same time learning this function, for example, display value came in as copy parameters. They cannot be and will not be changed inside this function. These are coming in as copy parameters, cannot be or will not be changed in the function. So we'll go ahead and do this. We will initialize largest here to val1, make the assumption that that is the case. Once we have done that, then we can start testing it. We can say, is val2 bigger than the largest one we have so far? If that is the case, then we will set the largest to val2. And then again, this is not an if-else if or an else. We have to test each of these conditions. So we'll test val3 greater than largest. If that is the case, then we will set the largest to that third value to val3. And then we'll return the largest value. Don't want to forget to do that part. And wrote quite a bit of code here. Compile. Happy compiler. Pretty straightforward, very clean, very easy to read, very easy to understand for anybody that looks at this. The get lowest value is going to be exactly the same thing upside down. So we'll say in smallest, we'll set val1 in there. Never, never, never use fake numbers like minus 0001 or minus 50 or minus 999 or whatever. Lots of stuff you see on the internet. All wrong. Always, when you're finding a maximum or a minimum, always start by using one of the data items in the set. Always do that. There's no other way to do it correctly. All right, so again, we're going to see here if we've got the val2 is less than smallest, then we know what the smallest one is here, at least at this point. And then we'll go ahead and independently again check the third value, less than the smallest. Smallest is assigned val3. And then when we're done here, we will in fact return the smallest. And again, a lot of code. We should probably be compiling about every line or two. But the compiler's happy here, and it looks like we've run out of things to do. So we're really done with step 6. So now what we should be able to do here is run this program the first time and see sorted values if we enter them in any old order. We'll go up and compile one more time and run. Bring it up here. We see our title. We see our screen getting way too big here. So we'll take the first value and we'll make it say 9, second value 5 and 1, and then values in sorted order are 1, 5, 9. Let's try it with slightly bigger numbers here. We'll try say 845, 516, and 231. We're putting them in reverse order, actually, largest to smallest, and it looks like we're working okay there. Just for grins, let's put it in order and see if it handles that okay. 5, 10, and 15, and sure enough it takes that okay. So it is very convenient to be able to write a program and watch it work the very first time you test it. It's also rather enjoyable because it takes all that fun out of debugging and hacking and trying to figure out what went wrong. Notice how clean and simple this program really is, and very abstracted. One part, this is a step one step. Get input from the user, action. Sort the three values, action. Display the values, action. This is very clean and very, very nice. Show title, action, and so on. When we come up here, again, I want to reiterate these. I've been through them before. This one right here, we sent nothing into this function. We didn't have anything to send to it. But we did have to put variables into it, as we found here. We had to put val1, val2, and val3 as garbage values. If these are values that if we were to, say for example, cout val1 and we'll do a system pause right there. Okay, if we were to do that and throw that out into the game here, it doesn't like that val1 was, oh, I'm sorry, value 1. Sorry, little guy, take care of you there. So value 1, not declared. All right, what am I doing wrong now? Oh. All right, value 1, run him up there, and in fact we see, and this is again unusual, very likely part of the compiler, it's actually giving us a 0, when what I would normally expect is a great big garbage number of some kind, or a very small garbage number. But nevertheless, it gave us a 0, but what we know is that at the time that we first declare these variables here, they are in fact, I'm going to take that out, they are in fact unknown. But we had to put them in here not for input. We're not sending anything to this function, but we are expecting to get data back from this function. So there was no input to it, but there was in fact 3 integers of output that this function gave back to us, giving us in fact what we got from the user. Here, now we had 3 numbers we needed to have sorted. So we sent 3 values into the function as we saw them as parameters, as aliases of the actual parameters. We did our fooling around inside the function, and when we got done, we came out with 3 values sorted, and that's why we had to have reference parameters. So this was no input, 3 outputs. This was 3 inputs, 3 different outputs, depending on how they came out. And then this one right here, the next couple here, next 3 actually display values and then get highest and lowest values. These are just processing function. Well, this is an I/O function that simply said, okay, I'll take those 3 values. I'm not going to process them. I'm not going to change them. I'm going to do anything with them except show them to the user and puts them on the values displayed as specified. The get highest value still isn't going to change these values. It's not going to mess with them. It's simply going to look at them, do some analysis, and give me back the highest number they could find in this group of 3. And this one does the same thing by giving me back the lowest number in the group of 3. So you've got an opportunity here to see many very different possibilities of how to use reference parameters and how not to, because you do not want to use reference parameters unless you have to. Reference parameters are a little bit, they're a little bit like global variables in the sense that you might start changing data from more than one function, and that's dangerous. But at the same time, if that function is supposed to make the changes, then in fact, that's what you wanted it to do. You know it's specified for that. If there's ever a debugging problem, you also know where to go to look for the problem. So we will go ahead and save and compile that one. We'll come back and we will finish this guy. And this is the video for designing and using the 6-step programming process with reference parameters in use, significantly in this particular one. More commonly, you'll have maybe 1 function or 2 functions with reference parameters in them, and then all the others will be copy parameters. But it really just depends on what you're doing. So you'll see that as you go along. And that will finish up this video.